Hello everyone. In this video, I'm going to explain about conditional probability. All right. So, what is this concept about? Well, this concept is, it is kind of hard to define it, so I'm just going to demonstrate it. So, this is a concept where first first of all, let's say we have an even A here, okay? So, with this even A, we can calculate its probability. And the probability of even A happening is PA, okay? And the probability that even A not happening is denoted as P negation A. So wait, this notation here means negation, where it means that even A doesn't happen. All right. So actually, firstly, we can make a square like so, square that tells the probability space of even A. And this is a space where even A could happen. And this is space where even A doesn't happen. Okay. And because this is probability, then one means that it is happening, and zero means it it doesn't have a chance to be happening. Okay, so yeah, this is probability space. So yeah, the length and the height would be one, and of course, this plus this is equal to one. And according to the picture, because it is here, then of course PA is less than P negation A. Okay, so imagine that this even this whole even happens. Okay, this whole even happens. Now there are two conditions that might happen. First, A I mean, after this even happens, then there are two conditions that might happen. The first one is A has happened, and the second one is A doesn't happen. So we can make a probability space where A has happened, and it is denoted by this small square of A. And of course, because this is a probability space, it has length of one, height of one, and length length of one. And so the same thing could the same principle also applies for the negation of A, where this is we can make its probability space. We can make its probability space, and this probability space means it is a space where A doesn't happen. Okay. Now let's take this probability space here. Okay. Let's take this probability space here. Now let's say there is an even B. Okay. Let's say there is even B. And B could happen in this space. in so we could say that B could happen when A has happened. Well, it seems obvious, right? I mean, this is a probability space where A has happened. So if B could happen in this space, it means that B could happen with when A has happened. Or in other words, B could happen given A has happened. Okay, so look at this word, given. Now, two sentences, these two sentences could be represented as this notation. Now, this line here, it means given. So so this sentences, I mean, oh no, no, this notation means that B could happen given A has happened. That's what it means. So if we want to make some calculation about it, so we can make a sentence like this, okay? So we want to count the probability. So we can make a sentence like this. Wait a minute. The probability of event B happening given A has happened is PB given A. And suppose that PB given A is 0.3. Okay, now we could draw a line here. Wait, oh, no. We could, I'm sorry. All right. Okay, we could draw a line here that has the same pro proportion with 0.3. So I guess it is around like this, right? Yeah, it is like this. And this could be represented as P P B given A. Now, as you can see here, wait, so as you can see here, because this is, it means that an even B could happen. The probability of even B could happen given A has happened. So it means that this side means the probability of even negation B when A has happened. Okay, and of course P in this space. Okay, so in this space P B given A plus P negation B given A is equal to 1. All right, and also P B A is fewer than P B A. All right, so this equation represents this condition right now. All right, so we can, plug these two variables into uh, into this probability space. So I have copied it here. So we plug these two variables to this probability space. So here 0.3 is proportion of 0.3. Let's say it is this one, okay? So here is P be given A, and here is P given P negation B given A. All right. Okay. And the same thing, the same idea could be applied for PA. And so this is P negation A. And then let's say there is an even B. And then as you can guess already, we could know P B given A not happening, and P B not happening given A not happening. Okay, so um I want to remind you that actually P B A doesn't might not be equal to P B A, and of course P B A might not be equal to P B A. Yeah, or here it means that not might not be equal, right? Might not be equal is represented as this. But of course, it might be equal either, but it might not be equal either too. Yeah. So let's say this in this scenario, P B A with A is 0.5. So yeah, just put it in the middle of the square. And this is, you can guess already, this is PBA. And this is P not BA. Now, we can plug these two variables into this box. So here, let's draw a line here that equally separate for the space of P negation A. Let's move it here. And then we can write this as P given like this, and so is this one. Okay, now the next thing that I want to tell you is that, okay, so let's copy paste this. Wait, not all of it, please. Wait. Let's move this here. All right. So here, let's say that, all right. So first of all, let's see here as PA. Now, this actually represents some kind of length, all right? And this is a height. And therefore, if we multiply these two variables, which is, wait, oh, I see. Yeah, like this, PA, like so, then we could know the area of this rectangle, right? And in this area, wait, let me use another. In this area, A happens and B happens. Okay. Or in other words, it tells us the probability of A and B. Or we could also represent this, we could also represent this notation as uh, P A B, like this. So what I want to tell you is that this multiplication means PA and B. It tells us this value. The same principle also applies for other areas, like for this one, then it means that P negation A times P, wait, what is it? All right, negation A equal to P uh, A and negation B. And this one means that negation B, then it is like this for this one. Yeah, and this one you can, yeah, follow along for as for this formula and this formula. So this visualization is very useful, you know. It will make solving problem a lot easier. And I hope you can use this concept, this visualization, to understand conditional probability. So I guess that's all from me. Thank you very much for watching. Please like, share, and subscribe to this channel. Assalamualaikum warahmatullahi wabarakatuh.